Hello dear student, this is Devansha from Engg Institute of Engineering and Technology. We are discussing about the subject which is called Basic Electrical Engineering, and subject code is 3110005. Right. So let's discuss the next point. To current if the resistance is constant. So you can see this particular by this equation you can say that voltage is proportional to current if the resistance is constant, and current is inversely proportional to resistance if the voltage is constant. So ultimately you figure it out, all this terminology like voltage you consider as a force, current is always in a motion. So you can see in this particular picture where the red balls are the currents which are continuously in a motion, voltage will act as a force, and resistance is nothing but your overall circuit path, right? So from this Ohm's law, if you follow this triangle, you can total get three equations, including all those two kinds of relation that we just discussed, where all these three equations are like V is equal to I into R, I is equal to V by R, and V is equal to I into R, R is equal to V by I, and I is equal to V by R. Right. Now based on this, you can see this particular relation is a linear relation, right? So you can see this graph here, where this particular graph where there is a straight line, and that particular straight line is nothing but it will follow the mathematical equation y is equal to mx plus c, where m is nothing but the slope. So ultimately here you can find the slope 1 by r is equal to delta I by delta v. So this particular Ohm's law is nothing but that will give you a linear relation of this parameters, right? So there are certain limitations of this Ohm's law, like it is not applicable to unilateral device or active devices like transistors, diodes. You cannot apply. It is applicable to the linear networks where only resistance exists, right? Same way you can also find the derived parameter of this Ohm's law, which is called a power P is equal to V into I, right? Now you can see this based on this resistance. Now we are going much detailing into a part of resistances. If you are going to connect if you are going to connect the multiple resistances in series, if you are going to connect multiple resistances are in parallel, how it's going to behave. So you see this, all the three resistances are connected in series, R1, R2 and R3, where if you check this, the current which is passing through all these three resistances R1, R2 and R3 is same, right? So I can say this here, the current I is equal to I1 is equal to I2 is equal to I3. So you can say this in a series resistance, the current is same, right? But the voltage is different. So if you find the voltage here, V is equal to VR1 plus VR2 plus VR3, or you can also consider the voltage drop across R1 is V1, voltage drop across R2 is V2, and voltage drop across R3 is V3. So ultimately V is equal to VR1 plus VR2 plus VR3, and if you apply the Ohm's law here, you can find the total V is equal to I into R1 plus I into R2 plus I into R3, right? Why? Because the current is throughout the operation is same, right? So ultimately V is equal to I into R, and that is equal to I, and you take the common from this equation, you have I in bracket R1 plus R2 plus R3. So ultimately the total series resistance RS is nothing but R1 plus R2 plus R3 here. From this particular figure you can check this. If you are going to add a number of let's say n number of resistances, you will find total series resistance is R1 plus R2 plus R3 and so on to Rn, right? Now this is the same case with the parallel resistance. You can see this here. Now current is now dividing into three parts, like one current, let's say I1 is passing through R1, I2 is passing through R2, and I3 is passing through R3. So here for this particular parallel resistance circuit, the value of voltage becomes same, right? So if you find the voltage drop across R1 is V1, voltage drop across R2 is V2, and voltage drop across R3 is V3. So ultimately V is equal to V1 is equal to V2 is equal to V3. But here the current is different. So here I can find my current I is equal to I1 plus I2 plus I3. And once you apply the Ohm's law, I is equal to V by R. So you from this equation you can write like V by R is equal to V by R1 plus V by R2 plus V by R3. If you see this complete equation, you will find 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. If you connect all these three resistances are in parallel. If you are going to connect n number of resistances, that means 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3 and so on up to 1 by Rn. Now, based on the series and parallel combination, you can find the voltage across each resistance. Let's say here you divide it into two rules. One is called voltage divider rule and another one is called the current divider rule, right? So, in the voltage divider rule, you can directly find the equation how much the voltage is dropped across R1 as well as R2, right? So, once you apply those equations like V here, total V is equal to VR1 plus VR2, since the value of current is same throughout flowing through R1 and R2. So once you combine all this equation, you will find it the total VR1, which is the voltage drop across R1, is nothing but, in this equation you can write the VR1 and you apply the Ohm's law. So you will find here VR1 is nothing but I1 into R1. Now since the value of current I is same, so I into R1 and I is equal to total application of voltage V divided by total resistance of these two series resistances. So V by R1 plus R2. So ultimately you will find this equation VR1 is equal to I into R1, and from this if you put the value of I is equal to V divided by R1 plus R2, you will find VR1 is equal to R1 divided by R1 plus R2 into V, right? So the voltage drop across R1 is nothing but the drop across R1, right? So that's a resistance R1 divided by the total of resistance into the total application of voltage. Same way VR2 is equal to R2 divided by R1 plus R2 into V, right? Now as such, here the series resistance will offer you voltage divider, as well as here the parallel resistor will offer you current divider, right? So this particular rule we define as a current divider rule. So here like in parallel value of resistances or parallel resistance circuitry, voltage becomes same but the current now is different. So I1 is passing through the R1 and I2 is passing through the R2. So you can also consider as IR1 or IR2. Now once you here apply the again Ohm's law and you take the ratio of total current I versus I1 or total current I versus I2, you will find here I1 divided by total current IT, that is equal to V by R1 divided by V by RP, and that RP is called the equivalent parallel resistance. So once you solve this particular equation, you will find I1 is equal to R2 divided by R1 plus R2 into total current IT. Now see, this is very interesting equation. Once you also calculate the I2, that is also equal to R1 divided by R1 plus R2 into total current IT. Right, now see what is alive here. In voltage divider, whatever value or whatever voltage drop you want to find of any resistance, that comes in a numerator, but this is not the case with the current divider rule. So I1 is equal to R2, not the R1. Remember, this is the common mistake the students are doing, right? So this is what the difference between voltage divider rule and current divider rule, right? Now let's say we enough talked about the resistance. Now let us discuss about the capacitor. So this is the symbol of capacitor. The unit of capacitor is in farad, right? How it looks like once you go to the market and you want to buy the capacitor, it's look like this way, right? And if you want to use those capacitor in a circuit, you can see the following images, right? Now what are the different functions of capacitors? So ultimately, what is the function of capacitor? Why we use a capacitor? So capacitor we use to store the energy in form of charge, and that charge Q is equal to C into V, right? So ultimately, it is not a straightforward element. Why? Because it also changes the behavior with respect to time. So ultimately, once you use this capacitor, you will have a rate of change of voltage with respect to time. So ultimately, this will give you a most important terminology which is called dV by dt, and that particular dV by dt we are going to use for the analysis of time domain RC or RL circuitry, right? Now so far our next component is called inductor. So this is a symbol of inductor. This is a unit is in Henry, and once you go to market and you can find this kind of inductors is looks like this way. And if you are to use in a circuitry, you can see all the components you can use in a PCBs, right? Now, what are the functionality of inductor? So ultimately, capacitor and inductor both will store the energy, but capacitor will store the energy in form of charge, but here inductor will store the energy in form of magnetic field. So ultimately, once we apply the current to the inductor, it will produce magnetic flux around it, and that particular flux is nothing but a kind of magnetic field which is being stored in a inductor. So ultimately, whatever here current you apply, that particular current you will find the variation with respect to time. So this particular inductor would give you a component, very effective factor, that is called di by dt. So this the capacitor will give you dv by dt, and inductor will give you di by dt. That those two particular terminology we are going to use in our further circuitry, right? Now, same way, we forgot to discuss in a capacitor, like energy stored in a capacitor, W is equal to 1 half Cp square, while energy stored in inductor, E is equal to 1 half Lsk. So ultimately, 1 half Li square. So ultimately, capacitor and inductor, right, both will behave with respect to time of variation, with the time or rate of change with the time. So ultimately, here the capacitor would give you actually, once you connect the capacitor in any circuitry and once you apply the DC, that means the voltage drop across capacitor, that particular charge is nothing but is going to oppose the applied voltage. So these two important factors is very essential to analyze any circuit or to design any circuit, which is dV by dt and di by dt. Right, so this is what about the RLC circuit. Now, if you recap everything, the most important part is the Ohm's law, where you find total three important equations, and that will give you a relation of voltage, capacitor, voltage, resistance, and current. And based on this, if you learn about the series and parallel, you will have a respective equations, right? So thank you very much, students. If you have any doubt, you can discuss in many below comments. Thank you very much. Thanks for your